Hello, everyone. I'm Professor John Nguyen, and welcome to Chemistry. Again, today we'll continue with alkanes, organic chemistry. Okay. Well, last time we named alkanes and alkene, and cycloalkane and cycloalkenes. All right, we're going to be looking at the a few chemical reaction of those two classes of compounds. Okay, alkanes and alkenes, and then we'll move on to alkynes, which has triple bond and aromatic compounds. Okay, well, there's only two reactions that's very popular for alkanes. The first one is the combustions. Pretty much any organic compound you can react with oxygens, burning it, okay, to give us energy as heat. For example, CH4 react with, this is a balance equation, two oxygens to give us CO2 and two water. We want to make sure all each type of atoms is balanced, meaning equal on both sides. Okay, so we got CO2 and water plus heat. Now, and we can do that for other formulas as well, like ethane or propane. We just need different coefficient for the CO2 if we have something with more carbons. All right, halogenation is when we react an alkanes and we replace one of the hydrogens. In this case, we're just going to do it once. With chlorine gas, like halogen gas such as chlorine. So notice that one hydrogen is replaced by the chlorine or chloro, and the other hydrogens will go, the other chlorine atom will go with the hydrogens to make HCl. Okay, so that's the equation is balanced. Okay, so that's alkanes. For alkene, because alkene has a double bond, so it tends to fill in the double bonds. For example, chlorine gas, halogen gas. Remember, carbon need to have four bonds, and double is one option, and that's known as unsaturated. So the chlorine gas has two atoms. Each can be added to each carbon. That's what's happening here. And when they add it to the double bonds, it's saturated, so there's no more double bond because carbon already have four now, four bonds for each carbon. That's what we get, 1,2-dichloro. Now we're going to take advantage of this reaction to learn the naming as well. Chlorine is called chloro, so that's 1,2, number 1, number 2, dichloroethane. Okay. Water. If you split up water, that will be OH and the hydrogens. Okay, so let's say you put a hydrogen on the left side, that make it a CH3, and you put OH on the right side, that make it OH. So basically you turn a double bond into an alcohol. That's an alkene, and that's an alcohol. And adding water need a catalyst, either H3PO4 or H2SO4, anything that has acidic hydrogens. Well, the third reaction is adding hydrogen gas, meaning two hydrogen atoms. So when you add two hydrogen atoms, this carbon right here, instead of carbon, C, it becomes CH. So please write it down, the products plus hydrogens with a catalyst like palladium, PD, on carbon/carbon, and that's work, or platinum, PT. Now, putting a hydrogen here, that's going to be our product, CH. No more double bond, it's going to be a single. And that CH right there becomes CH2. So each carbon of the double bond gain a hydrogens. All right. Now for this one, you just simply put the hydrogen here and hydrogen here. Okay. And you don't even have to show the hydrogens. And take the double bond away. Hydrogen here, hydrogen here. Okay. Now, making a polymers is very interesting for double bonds, like polyethylene. You're looking at polyethylene. It's a very popular um, polymers for material that we use every day. Okay, we make a lot of them, billions and billions of tons of polyethylene. Poly mean a lot, ethylene mean alkene. So the double bonds, it's gone because we connect many units, same molecules together. Okay, all right. Okay, so those are reactions, popular reaction of alkane and alkenes. Now we're moving on to alkyne with naming. Similar to alkene, we have the numbers on the side that's closer to the triple bond. 1, 2, 3. We got a triple bond started with carbon number 3. 4, 5, 6, 7, 8. All right. So number 6, we have a methyl. That's what we call 6-methyl 3-octi because it's 8 carbons. Now that's a new IUPAC name. Instead of 3-octi, we can call it oct3i. Sounds kind of weird, but it's actually very helpful when we have multifunctional group, but we're not responsible for that now. Okay, let's practice. Name this one here. So if we start on the left side, 1, 2, 3, we got an alkyne number 3. We start on the right side, 1, 2, 3. So it doesn't matter which side, they both, equal. Again, so 1, 2, 3, 4, 5, 6. So 2, we got a methyl. 4, 5, we have another methyl. So that will be 3, 5 dimethyl 3 hexyne. Okay, so please write that down. All right. All right. Okay. In terms of reactions for a triple bond, we can add it 1 times. Remember double bond, we added 1 time, the double bond's gone. But the triple is different. We have to add 1 time. We go from triple to double. We have to add another time to get to the single bond. Okay, so let's say we add HBr. The bromine is going to go to 1 carbon and the hydrogen is going to go to the other carbons. Well, this reaction is a little bit complicated, okay, but hydrogen always go to the outside carbon and the bromine always go to the inside carbon. Okay. Now, if you take more organic chemistry, we're going to go into the detail of mechanism to explain why they are added that way. Okay. If you do the second one, the bromine go to the same carbon, inside carbon, and the hydrogen goes to the outside carbon. And the naming is nice too. Take advantage of this to learn the name as well. 1, 2, 3, 4, 5, 6. So that's why it's 1 hexyne. 1, 2. So that's why it's 2 bromo, 1 hexene. And then we don't have any more double bonds or triple bonds. So just 2, 2, 1, 2. So you got 2, 2, another 2. Dibromo hexane. Very nice, right? Now, we can also add bromine just by itself, 2 of them. If we add it once, we got 2 bromine trans. And by the way, E is for trans, but you guys are not responsible for that for now, okay? You add another one, you have 4 of them in there, and that's the name, okay? 1, 1, 2, 2 tetrabromobutane. Okay, let's try those practice. 2, so we got 4 Cl, right? So on the paper, just draw them out 4, meaning you have 2 on this carbon, 1 Cl on top, 1 Cl on the bottom, 1 Cl on top, 1 Cl on the bottom, and done. We don't have to worry about triple bond anymore. It's gone. Now, if you only have 1, you only add 1, the Br is going to be added to this, and the hydrogen is going to be added to that. So we still have a double bond. Okay. Now, moving to the last topic, that's for this chapter, that's aromatic compound. Any molecules with benzene, hexagon with 3 double bonds. If there's a bromo, one branch, we don't have to number it, it's bromobenzene. Nitrobenzene, NO2, propobenzene, 3 carbons. We got a lot of branches here, so we have to start numbering them. 1, 2, 1, 2, close together, 3, 4. Okay, if we go the other way, it will be farther away. So we got even bromine come later. The reason why we put 1 here because we have 2 branches close by. So even this number later, they still have to go first because alphabetical order. So that's why 4-bromo 1,2-dimethyl benzene. All right, moving on to the next one. 1 is right here. Notice when you have the benzene with the OH, we call that a phenol, and that's automatically number 1. And the reason why we go clockwise because the branch number 2, we got a branch, 3, 4, 5. We have another branch, but this one's got to go first because it's closer, rather than the other way. Okay, so that's 2,5-dimethyl phenol. Phenol again is a benzene with OH. If you have a benzene with the CH3, that's called toluene. And it doesn't matter which way you go, the 3 branches are in the same number system. It's always going to be 2, 4, 6. 2, 4, 6. You go clockwise or counterclockwise, the same. 2, 4, 6. Trinitro, meaning we have 3. Nitro is NO2, and that's toluene. This compound is also known as TNT, a very popular explosive. Okay, we got benzene with the NH2. We call that aniline. And that's 1, 2, 3, 4. So that's 4-bromoaniline. That's called benzaldehyde. Okay. Benzaldehyde, benzene aldehyde, we call it benzaldehyde. That's benzene and carboxylic acid, we call benzoic acid. Benzene with OH, as you've seen earlier, it's called phenol, PHENOL. Benzene with methyl, we call that a toluene, TOLUENE, toluene. Okay, right here, toluene, TOLUENE. Okay, so you guys can write those down. And we should be good for this one. Functional group, hydrocarbons. We should be good for these chapters. All right, thank you everyone for watching. See you guys in the next video. We're going to move on to the next few classes of compound. That's alcohol, aldehyde, ketones, okay? And then finally, we're going to move on to carboxylic acid, amine, and amines, all that stuff. Okay, thank you everyone for watching. See you again soon.